Okay, number 11, we're finding cube roots of the complex number 8 plus 0i. So the first thing we need is n. In this case, if we're talking about cube roots, that's to the third power or to the third root. So n happens to be 3 because it's cube roots, not square roots. The next thing we need is the modulus. Now, the nice thing is we have 8 and we have 0. So all we really need is 8 because 8 squared is 64 plus 0 is the square root of 64, which brings us right back to 8. The last thing we need is tan inverse of 0 over 8. Well, the tan inverse of 0 is 0. So since everything's positive, we know we're in the first quadrant. So 0 is the argument. So we have an n, we have the r, we have theta. So k equals 0. So all we're doing is plugging this into our root formula, which looks a lot like our power formula. So 8 plus 0i to the 1/3, because we're taking the cube root. So the first thing we do is take the cube root of the modulus. So instead of the square root of 8, we're taking the cube root of 8. Cosine of the argument over n, so 0 over 3 degrees, plus I times the sine of 0 over 3 degrees. Now, the cube root, we can put that in the calculator. The cube root of 8 is actually 2. Anything, if the numerator is 0, leaves us with 0. I don't care what the denominator is. So we're just taking cosine of 0 and the sine of 0. Once we get to this point, this is familiar with everything else that we've done. All we're doing is finding what the cosine of 0 is, what the sine of 0 is, and then converting it to rectangular form. So the cosine of 0 is 1. The sine of 0 is 0. So we substitute that in. The last thing we need to do is distribute the 2. 2 times 1 is 2. So we get 2 plus 0i. So remember, this occurred when k equals 0. So whenever we're finding that very first, whether it's square roots, cube roots, ninth roots, k equals 0 is always where we start. So we started with just 0 over 3 for the argument. So the next thing we're going to deal with is when k equals 1. So a lot of the stuff is still the same. N, R, and theta are all identical to what we started with. So we're going to fill in this formula with those values. The difference is now k is 1. So instead of just having 0 over 3, we have 0 plus 360 over 3. We have 0 plus 360 over 3 for the sine as well. So that's the only thing that changes with the second root. Everything else stayed exactly the same. So now we calculate 360 and divide 3, and we get 120. So then we have to calculate the cosine and sine of 120 degrees. Well, the cosine of 120 is negative 1/2. The sine is radical 3 over 2. And remember, that kind of makes sense because at this point, we're in the second quadrant. Now we distribute our 2, and our result is negative 1 plus radical 3i. So there is an I at the end. I don't know if you can quite see it in our video or not. But the result for this root is negative 1 plus radical 3i. So it's cube roots. We need to do the third one when k equals 2. So this time when k equals 2, everything stays the same except now we're multiplying 2 pi by 2. So 360 times 2 gives us 720 degrees. We divide 720 by 3, we get 240. So we need the cosine and sine of 240 degrees. Notice 240 is in the third quadrant. They're both going to be negative. So we get negative 1/2 and negative radical 3 over 2. Then we distribute our 2. The 2's cancel, which gives us negative 1 minus radical 3i. And those are the 3 cube roots of the point 8 plus 0i.